All right, so what we've got is we're going to have a look at an ogive. Now, the ogive looks similar to a polygon from a frequency histogram, but the ogive appears on a cumulative frequency histogram. So they have given us a frequency distribution table with group data, with all of the data in there, excuse me. It gives us the number of customers who order different volumes of concrete from a ready-mix concrete company during the course of the day. Find the interquartile range of the data. Now, most of that is just, who cares? Okay? We don't care. We really don't care. What we want is the data and then we'll work it out. The fact that they've given us a context is lovely, but mathematically it doesn't make any difference. Okay, so what we've got is the volume and the frequency. Cool? Excellent. So, we have to now fill in this table. If they had given you this and you just wanted to add to it, go for it. If you had this, like my guys have their booklet, they just fill it in. All right, so what we're going to do is we're going to fill this in. So we've got I've got to put a pen on there, that'll be useful. 0 to 0.5, 0.5 to 1.0, 0, 1.5, 2.0, 2. I hate the fact that OneNote doesn't believe me. All right, 0. So I'm assuming you guys are all doing this as well. 1.5, 2.0, 2.5, 3.0. Okay, class center. You guys remember how to do that?
Class center?
Yeah.
Yes, the middle of the center, it should be 0.25.
Yep.
Let's go up by 5.
Close. What are you going to go?
Yeah, 5. That's what I said, we're going up by 0.5.
0.5, not by 5. Okay, frequencies have already given us. So 15, 12, 10, 8, 2, 3. Okay. Now, cumulative frequency. What do we got? First one, what's the cumulative frequency? Come on.
15.
15, excellent.
And 12 plus 15.
Or 15 plus 12, take a pick, doesn't matter.
27.
Yep. Then what?
37.
Yep, then what?
45.
Yep, then what?
47.
Then what?
50.
Excellent. Now, they told us, they didn't tell us how many there were, but we've got 50. All right, everyone happy with that? Yeah? Sure?
Not really.
Not really? A little bit sad?
I have to grab it.
Yeah, now you have to graph it. Luckily, some legend gave you graph paper.
Yeah, it was me.
None. All right. You guys, Kale and Jake, you happy with that? Cumulative frequency and all that?
Yeah.
Okay, fairly straightforward. Go over here. Whee! Whoa! Contact. All right, now you'll notice they've added something on the on the vertical axis. Okay. Do the volume across the bottom with the class centers as we do. Now, when you do it, don't forget you're leaving half a space at the front, and then you've got to leave double it. Yeah, it's the ghost of Christmas wind. Okay. Because the columns are going to be touching each other. Now, on a cumulative frequency histogram. Sorry out there, that just fell down. Notice there's one significant difference between, sorry, I'll come back. Notice there's one significant difference between the frequency histogram and the cumulative frequency histogram. Have a look at the first column. Tell me what the difference is. You have 5 seconds.
lowest number.
Close.
Starts on the edge.
Thank you. Starts at the corner. Have a look at the frequency one. It didn't start at the corner. It had a small gap. It had a half unit gap. Okay? Before it started. That's so the polygon could come down to the corner.
Yeah, there's
Cool.
no polygon in this one.
There's going to be an ogive. Okay? But we start right at the edge. Everyone happy with that?
Yep.
Okay. So, you basically, if you're doing 1 centimetre columns, you mark out every half centimetre and you're getting where the class centre should be, and you're also getting where all the columns, the actual lines should be. Cool? So actually I might put them in because I'll use them myself. Okay. So that's where my column is going to go. So we're doing cumulative frequency, so we know it's going to keep going up and up and up. So what have I got for 0.25? What's my cumulative frequency there? 15. Okay. What about 0.75? What is it? 17? Yeah? No, it's 27, wasn't it?
Yeah.
You're not helping me out here. Help a brother out. 27?
37.
Yeah, I gotta do 27 first. Then 37?
Yep.
Then what?
44.
45?
Yep. 47.
Then 47?
30.
Then 50?
50.
50 in the house. That's a dodgy one, but that'll do. Alright, so we've drawn our histogram. We're all happy with that?
Yep.
Yeah? Now we have to draw the ogive. How do we do that?
On the edge of the corner. The left edge. And there.
Sorry, top right, not top left, sorry. My bad. Jeez, I do that a lot.
Famous lines, is it?
Yeah, I lied to you. I lied to you. What are you going to do about it? See me. Alright, so what do? We start from down here. At
So
0.
from 0.
Yep.
And go to the right.
And then we go up to the corner of each one. Okay? So there, there, there. And you join it with straight lines using a ruler. Do you reckon it's important that you use a ruler?
Yeah.
That was supposed to land on the table in front of you, but it didn't quite. It is important that you use a ruler when doing the ogive. It is also important, yeah, no, that's a spirit level. It is also important that your graph is accurate. Why? Because we are going to be reading data off your graph, off your diagram, and off your ogive. So if they're not accurate, your results will not be accurate. Does that make sense? All right. The question then says, find the upper quartile, or the 75th percentile, and the lower quartile, which is the 25th percentile, from the ogive. What do you reckon you do? Seeing as we've got the percentiles on the left. Anybody?
Question again.
Find the upper quartile, 75th percentile, and the lower quartile, 25th percentile.
2 quarters.
Let's go up and find the 75th percentile first. There's the 75th percentile there. So we then go across
Straight across.
with a horizontal line until you hit the ogive.
And then you get down, straight down.
And then you
the
go
back.
straight down with a vertical line. Cool?
Yep.
Now mine's not perfectly accurate because I'm not using it all.
Yeah,
Then the
that's
25th one. You go across from 25% until you hit. And you come down.
Take that value.
Okay.
There's your answer.
Now, depending what scale you did your graph at, you may be able to read off exact values. We're going to approximate. We know that that's 1.25, we know that that's 1.75. What's that line going to be at? That line there, the purple one, the actual end of the
Purple
column.
line should be 1.5.
It will be exactly 1.5, as long as you're drawn accurately. Now we're just to the right of that. So let's say it's 1.6. Happy with that?
Yeah, well,
Yeah.
close.
1.6 is what we're going to work with, yeah?
Yeah.
Now this other one, we know that that's 0.5, so let's say that's 0.4. The reason I'm actually choosing those numbers, because mine's not very accurate, is I know they're the ones that are in your book. Okay, so, but it's just above the 1.5, so you approximate, and if you've drawn it to a big enough scale, you can actually get the exact number. And the other one will say it's 0.4.
Also within human error.
Yeah, well, all measurements are approximations. Every measurement is only correct to within plus or minus 0.5 of the smallest measurement unit used. So if we're using millimetres, then you are always going to be plus or minus 0.5 of a millimetre out. If you're saying Dubbo is 160 kilometres away, you are plus or minus 0.5 of the smallest unit used, whether it be kilometres or 10 kilometres. So it could be 165, could be 155. No.
5, yeah, 10.
Yeah, plus or minus 5. Alright. Or it could be 160.5 or 159.5, depending whether you use 1 kilometre or 10 kilometres.
Closer.
Or 5 kilometres, then it could be 2.5 like that. Okay? So plus or minus 0.5. But yeah, within human error. And to be honest, if you came up with 0.45 and 1.55, no one cares, as long as you then do it correctly. Okay? We're trying to get, I mean, if you're within that, and there is a range, HSC markers and all that will have a range of numbers that are close enough. Okay? Because it's not, we want you to be able to measure it. If you got 1.2 there instead of 0.4, we go, no, that's wrong. But 0.3, 0.4, 0.45, not bad. If you got 0.5, we'd say you're wrong. Because 0.5 is that line and you need to be able to know that. Cool? But there is human error allowed. Alright, so then you've got, how do you work out your IQR?
Interquartile range.
Yep.
The range of the two.
Yep.
And then you take
QL minus Q, so QU minus QL. Okay, upper minus lower. So 1.6 minus 0.4 gives us an IQR of,
1.2.
now you'll notice, they're using squiggly equals. What does squiggly equals mean?
Oh, that's,
This.
yeah.
The same as that.
Therefore,
Nope. Therefore is
the $3.
that. Now what were we saying about measurements? They are all,
Equal
oh,
numbers
ah,
of
approximations. That's what that means.
approximately.
Approximately equal to. And you know how you do that? You sort of go, it's about there. Right, everyone happy with that? Okay.